take a look at Gable studs. Find the Roof Cutter Secrets 5961 if you're interested. Trick to Gable studs, what we want to do is find it's called a little step for the Gable studs, and that's pretty easy. Remember how I had showed you before how to find the line length ratio? I mentioned there's what's called a rise ratio, and I use that to find heights. It would be the same right triangle, 7 over 12. We would take the 7 and divide it by the 12, and this is actually tangent, trigonometric term. 7 divided by 12 is going to give us 0.5833. So now if we want to find a change in height for any given run distance, we would multiply it by that 0.5833. So let's take 16 inches and we'll just multiply it by 0.5833. We'll come up with 9.33 equals, for 16 inches, we'll have 9.33. So come over 16, it's going to go up there. Now, typically, what we would do in the track is just use one Gable stud step as the starting shortest one and just step up from there. Let's take a look at another option, though, if you wanted to do it a different way. I'm going to draw 3 plates here. This is your top plate, this is your double plate, and this would be like a 2x6 drywall backing. On top, these are 2x4, let's just say. Most walls are probably 2x6, but let's just go with that. This is drywall backing. Okay. And let's pick a point, we want this guy to be in. Typically your shear panel will come up to this guy, so you'd end there and you start your next shear panel. Probably run horizontal, so it doesn't really matter. But let's just say we wanted to be at 15 1/4. Okay, this is versus just using my first one as 9 1/4, 9 and a little over 1/4. So that 16 would be from here to here, and this would be 9.33. Let's say we wanted 15 1/4 for spacing, we want to line up. So what we need to do is find that distance over to here and then subtract it from the 15 1/4. Well, we already know our bird's mouth is 2 1/4. And you can see this is a little tiny right triangle there that's this is our 2x4 nailer. I just forgot to mention that. What we want to do is there's our rafter. Taking a cross section on a rafter, 2x8 rafter, let's say. We want to run a 2x4 nailer flush on the outside. The reason we want to do that is because we're going to stack our Gable studs right on that and get good nailing from the inside. Outside here, you're just going to be able to get one kind of toenail into it, or you can always run some nails up this way, but it's a lot easier just to have an end nail from the top. Okay, so we want to solve this little triangle. I'm going to draw it. This is our 2x4, and this is 1.5. You'll notice there's a little right triangle. I want you to, throughout this course, start to visualize triangles and never place them. That's a 6, 7, and 12 triangle, so that's 30 degrees. So we've got a 7-inch pitch, put in 1.5 as our rise, which is the rise, and we're going to ask for the diagonal. This is the diagonal right here. That would be the run. This is the rise, run, diagonal. So we got 2.9769, so we'll go 2.98. For all practical purposes, this is about 3 inches. So we'll just call it 3, and we've got 2 1/4 plus 3. We've got 5 1/4, and so we'll take 5 1/4 off of this. So we've got a 10-inch would be to our first Gable stud. So our first one is going to be different than all the rest because it's shorter. So to keep this on center spacing, so we got 10 inches would be our run. I'm going to ask for a rise. I'm going to come up with 5.833. So I'm going to change pens so you can see that. So in this little triangle here, we've got 5.8 3 for 10 inches. So our first one in this case will be 5.833, and then our next one will be 5.833 plus our step that we figured for 16 inches on center. If we're going to go 6.933 and continue. So our next one would be 9.33 and until we don't need any more. The trick to Gable studs is how to cut them in a gang style so you're not spending so much time and wasting wood. The way to do that is, say this is our wall, this is our plywood, this is the wall. What I do is just take, let's just say we're going to need 3 Gable studs, just like 1, 2, 3, just what's in this drawing. I'm going to put one down on the bottom, kind of like a filler. And you'll see why. We're going to put another one. Length on these guys, typically I just run studs. That's what's available. In this case, we're not going to run studs because we're just, for our mock-up, we're only going to be less than 2 foot high. So you don't need, but typically you just run studs out and then you use the studs. In this case, we're going to say we have 24 inches. Okay, we'll take our first one. I'm going to go with the method where we just, the shortest Gable stud is the length of one stud. I'm going to come over here and we're going to mark it. So we're going to mark 9.33. And I'm going to take a small piece of wood that I would use as a little step that's exactly, this is 9.33 right here. Okay. This is 9.33 and I'm going to, just a little tiny, usually it's a little piece of 1/4 by 1.5 inches, just a shim, whatever, just cut it to the right length and you don't have to use your tape measure. Then we would set it there, mark the second one down, move it over, mark the third one. So now we've got 1, 2, 3. Now we're going to pair up, so this is our shortest, our second, and our third one. What we want to do is we want to pair the other side, coming down the gable, with the first set that we have marked. And in order to do that, what we want to do, since this here is a short point, if you can imagine this guy, we want to pair it up with another one as a long point. Okay? And then we're making one cut, one angle cut for each of these Gable studs. We're going to get 2 sets. So on the longest one down here, what we need to do is find the, what we want to do is find the long point, because then we can pair it up with the short point one right here. So we would actually end up putting a let's just say this here, this dimension right here is 9.33. We want to find out what's the long point. So we can pair it up and make our mark right there. So how do we find that long point? We already have been using this, the rise function of the Construction Master Calculator, or the line length, the rise ratio. So we just say, here's our stud. Okay, this is our short point. This is 9.33. How far? We've got a little triangle there again, right? So this is 1.5. This is the thickness of our 2x. Punch it in our calculator again. Find the calculator. Here she is. It's clear. We'll go 7-inch pitch. We'll go 1.5 is my run. I'm going to ask for my rise. Let's 0.875 is 7/8, so we're going to come up to 7/8. So if I want to do this, I would add that one to the 9.33, and from here to here would be 10.21. Well, it's a little under 1/4, so we'll just call it 1/4 for you guys. So 10 1/4. Now what we'll do is we'll take this, measure it all the way back to the end there, and let's say this would be I can tell you exactly, 9.33 times 3 equals, this one here is 27, I call it 28 inches, and we'd add that 10 1/4, so we have 38 1/4, and now we bring that right up to the top of the pile, that same measurement. 38, what did I say, 38 and a half? 38 and a quarter. 38 and a quarter. Draw a line there, snap a line there, and I cut this with a chainsaw. Line on the other side and just straighten out the chainsaw. But once again, if you're not used to that, don't make a cut at all there. Just come back here, set your saw at 30 degrees, cut this one, chuck that guy off. It'll expose the second board. Make that cut across. These are 2x flat, I should have said. I think that was obvious, but let's just say this is a flat. Okay, so you need to set the blade at 30 degrees, and you need to set it so it barely passes the thickness of the wood of one Gable stud. Make your second pass, get rid of that one. Make your third pass, get rid of that one, then come back and just square cut these three. But like I say, typically I would just chainsaw that. Now, if you got a bunch of Gables on the house, well, you'd be doing a whole bunch of stacks at the same time. 2x4 across. So this line here would be all the way across. The first one, we make our cut there. You'd have your mark on the second one. You would have stepped down the other side of the pile. And now you've got snap your second line, follow that one. Third, get rid of those guys. So you can see why it's really nice now to use a chainsaw to cut the ends, because then you don't have to cut. You can do 4 or 5 stacks, the length of the bar of your chainsaw, and this is a good sharp chainsaw and powerful. It will have no problem going through there. You get a pretty good cut there. When you're stacking these guys, well, it's in my mind. What I do is I come in here and I set a little set nail right at my 16 inches on center, so I'll know where this guy planes in, and put a 16, 16, 16, so that when I'm there, I'm just going to slap this guy up and shoot one down from below, and at the bottom, I don't have to worry about the bottom moving, and then just toenail. And two toenails in here, so that guy just stays, that little set nail. I think that about covers them. We're going to actually do just a few Gable studs, but we're actually going to go for 8-inch Gable studs. So let's go ahead and calculate that. Since we have such a small amount, we'll figure the step for that right now. We got 8-inch run. We're going to ask for the rise. For an 8-inch run, we got 4.67, so it's about 4 5/8 is our step for our markup. We're going to move real quickly on to calculating ridge heights and common rafters that sit on ridge beams, things like that, because we've been working on our calculating rise, and it fits right in there. So we're going to do a hypothetical right here. We've got a ridge beam centered on a, I don't know, let's just say give it a 120-inch span. And we're going to say this is a 4x ridge beam up top. What do we set that ridge beam at? It should be the same if you're going to be calculating tall walls, by the way, guys, if you know, a distance over to something. So first thing we're going to do is we're going to take that span, enter 7-inch pitch. That gives us the right ratios. It pulls it up automatically. So now we're going to say we have a 120-inch span. We're going to subtract out 3.5 inches for the thickness of the 4x. Divide by 2. We're going to come up with a effective run of 58 or 58 inches. Store that one, and then we'll make that 7-inch pitch as our run. We'll call 1 as our run. We'll ask for our rise, and we got 33.979, so 33.98 would be a rise from plate, top of plate, to top of beam. And how about if we should have figured out at the same time as we were calculating that rise, we should have figured out the line length at the same time. So let's go backtrack real quick. And 120 minus 3.5 divided by 2 is our run, and equals, we call 1 run, we've already figured our rise, 33, and we'll hit diagonal, and that'll figure our line length. So we're going to say this is our rafter, 67.43 heel cut to heel cut. Heel cut here, red, as you can see, heel cut to heel cut. And you can notice that's just a little right triangle. Look at the little right triangle down here, 11 and 12. Using Pythagorean theorem. Talking about how we lay out this guy here, bird's mouth, heel cut. Now, what about if we want to lap these rafters? When I was in a track, what we do is when I was a stacker, they just cut the bird's mouth, and we'd actually end up cutting this in the air. But I myself started just cutting them all. I don't know why we shouldn't, because it's all done. You don't have to do anything cutting it in the air. Here is exact same thing, but it's not 67 and 3/8, obviously. I'm going to say this guy, I figured this for a 24-inch span. This would be like a small 24-inch minus 3.5 divided by 2 equals, that's our run, is 10 1/4, and I asked for a diagonal, I got 11.86. So here I'm going to make a little note here. Diagonal is 11.86, and that was for a 24-inch span with a 4 bar in the middle. That's what this guy is right here. So it's been laid out for that. So I should be able to see that right at 11 7/8. Right, the layout to cut the back cut by ganging it. Here is our plumb line right at the upper heel cut. We come over half the thickness, which is 1 3/4, half the thickness of the 4 by, to find the center of that ridge. And that would be this guy. And then what we want to do, I just make a pattern, the opposite ridge, and a ridge cut. This is 7 and 12. I place it right against that guy, flush, just like if it was centered up, and that's when I get my cut line. And in this case, it just by chance happens to work out 30 degrees. If we set the saw to 30 degrees, we can make that, but it's just kind of rare. Normally it's 90 degrees minus 2 times the roof pitch, but in this case it's 2 times 30 is 60, so we end up with 30. If it was something else, for example, 90 minus, let's say, 10 and 12 would be 40 degrees, 80 degrees, 2 times 40, we'd end up with 10 degrees. You have to check me on that as far as what the pitch of 10 and 12 is, but I think that's what it is. So this cut would be 10 degrees, and of course you can see the difference. It just by chance it works out to be 30 degrees. So we snap a line right there across the top of the pile, in red, and use our head cutter and make this back cut right there, so that when we stack these guys right up on top, we would have that cut right there automatically. You probably want to come in just a smidge. I do. You don't really care that they're short a little bit, because if they're short, let me draw this here. If they're short just a little bit. The other one, the top of the other rafter is right there, and it's short just a little bit too. So, what, you have a little coordinates, but that way at least you don't have to worry, oh, this one's a little long. Covers you there. So now what happens, another thing about cutting these guys, well, when you get down too shallow, once you go below 5 and 12, I think it's the cutoff, if I can recall correctly, you're getting beyond the limit of most saws. The head cutter's going to have trouble cutting much more than 45 on that long of a cut. So what I usually do there is I'll set this up so that it's on the end of the board, and that's what I would move my center over. Let me draw out a little bit here. Coming in, and let's just say we're 4 and 12. Okay. So what I do is I set it up so that I drew all this out so that instead of coming all the way up to the top of the pile, where I can't get that, what is 4 and 12? It's like 18, so minus 18 twice, 18 a quarter, 36 and a half. The complement of that would be, my math's not that quick, minus 36.5. Yeah, okay, 53 and a half degrees. So it's very shallow. So by setting it up so that the cut is on the end of the pile, or will be on the end of the pile, let's say you do this and it comes all the way up there. Make it a 90-degree cut, which is easy. Then come back on the pile and snap a line where this guy intersects the end of the pile, and now you can set your saw up at 2 times the roof pitch at 36 and a half, and make this cut right there, following the end of the pile of wood. That makes sense. And you're all cut. The reason why we did them in the tracks, let's let them go, was because of this. Typically they're 4 and 12 and stuff like that, and it's just way too big for a saw to cross cut or to gang cut that kind of a rake. So they just say, cut them in the air, so as you're stacking, you're just up there with your skill saw and slap them side by side and use it as a guide to cut the one right next to it. Okay, talk about if you want to figure to the height of the top of a ridge beam. Another situation, let's take the same hypothetical 120 inches again, outside, we got 4 by. Instead of sitting on top of this 4 by, they butt to this 4 by like a ridge board, but this is a beam. How would we figure this height? Well, what we need to do to this dimension here is this 33.98. All we have to do, we've already done the same triangle. Let me see if I have my red. We've already calculated the same triangle. Well, we know to there is 33.98. So what we need to do is add that heel stand dimension right there. And in our case, it's 2 3/4. So this would be 33.98 plus 2.75. And I'll check that out on my calculator to see what we end up with. 32.98 plus 2.75. We got 36 and 3/4. From top of plate to top of beam. The reason I said that top of plate, top of beam, because then a lot of people come in and say, okay, well, I've got a post here, I've got 8-foot walls, I'll add 96 inches to that 36 or 97 or 96 and 3/4, whatever, we'll just use 96 for simplicity, plus 96, we've got a total height of 132 and 3/4, and we're going to say this is a 7.5 inch beam, so we're going to take off, make this a 4 by 8 up here, we're going to take off 7.5, and we're going to have 1/4 off of 132 minus 7 equals 125. So we're going to have a post of 125 1/4. That's in a perfect world. Perfectly flat. Point outside wall, perfectly straight. Now we're going to come up with a wall that's 96, and it's perfectly straight. So we know this point, this point, and this point are level. We could do that. I don't think you're going to find a single house that's that way. What you really need to do is you really need to figure off of a string that's going from wall to wall. So if you have a crown, it doesn't matter. If you have a belly, it doesn't matter. You know your height is 36 and 3/4 from this line up. Now all you've got to do is measure down to the floor from that line, and let's say it ends up to be a 1/4 swale right here. So we're going to be 96 and 1/4, right? will be added to that 36, and we'll end up at 125 and a half. This is a common problem. A lot of people are kind of starting to get into little stacking problems, and this is a good point. Let's talk about the same thing that will happen right there. How many times I get people come in and say, well, it doesn't fit. Okay, why doesn't it fit? First reason is I'll usually look at this. Next reason is I'll probably check those dimensions. More than likely it'll be one of the two. If you can imagine, if this post, if it was set correctly from the string, what were we, 36 and 3/4, 36 and 3/4, it would be exactly where my rafter is going to hit. But if it's set, if you measured and set your post off of that 1/4 inch swale, we're going to be down 1/4. Well, what's going to happen? We're going to stack that guy up there, and it's going to be an open bird's mouth right here, right? Because it's down, it's going to push that out. It should have been here. I was going to butt to it, and it's down a little lower. It would kick that out. Same thing if this is up high. Okay, so if this is up high, I'm going to draw over myself. Apologize, guys. Another wall out here. This is higher than it should be. You're going to have that bird's mouth. Bad drawing. That bird's mouth is going to be open up top because the ridge is higher than it should have been. It's higher than it should have been, so this is going to be open. It's the only way. It's just math. And likewise, if you had some rafters that should have butted to this, and that your height should have been here, and this would have dropped this down. These guys, now, they're going to fall to here because it's high. Whereas if this beam was at the right height, they would flush out. So those are a couple errors in the cross-section of the building. The reason the ridge needs to be very straight, guys, is if your walls are straight, as they should be, and we'll talk about that in a second, and you put a crown ridge up there, and you didn't think about it, these rafters are going to come across there. I don't know how many times, the rafters are short. No, it's because that ridge, these guys are cut mathematically. They'll fit right on that line, as long as you're outside wall. And here's the other problem, is how many times you guys line the wall, you're looking for in and out, okay, if that wall is laying out or if that wall is coming in. How many of you guys look for the swale in the wall? Okay? Not only does it need to be lined in and out correctly, it needs to have that plate line be straight across here. If it has a swale to it, well, that's fine. What's going to happen? They're going to be stacking here, and so here's your straight ridge. They're going to stack the same way as that swale in that wall is. So keep an eye on that, and that's why I think I say in the book, that when you're, sorry about this, guys, if you've got a swale, you need to straighten that up. Shim between the top plates so that this line is straight. If you've got a bow, a crown, I should say, you need to trim that guy off. So you have a straight line, not only in and out, but up and down. And we'll get into some of the other problems when we get to hips